over all of the homework, but I'm just going to pick just a couple problems and go over just a couple. And because I told you that you did not have to do the squares, because the squares are not my favorite strategy, and because I know that the squares can look a little bit confusing. Put your homework out so you can actually check it. You know what yours is or is not. I want it very much. So the main thing that you were supposed to do is you were supposed to rewrite each expression as a number sentence with decimal factors. And so what they did is they took these right here. We have 1/10, and then we had 1 6/10. So if we had 1/10, and then we have 1 6/10. So I'm going to pluck out that decimal, and I'm going to make it 16/10. So I'm going to do my smoosh math and do 10 times 10. 1 times 16 is 16. 10 times 10 is 100. 1600ths. My decimal should move in 2 places. So 16, I'm going to start over here. My decimal goes 1, 2. So it should look like this when I'm done. Yes, ma'am. Well, then if you kept your denominator as 10, then it would have really ended up looking like this. Then you got lucky. Because if your denominator was 10, it shouldn't look like that. You would have only moved your decimal once. So you got lucky. Yes, Melanie.
When I did it, I didn't complete, like, I did it, but I didn't answer it. Like, I didn't.
You didn't write the decimal part? Well, that's okay. I mean, I wasn't, like, being a mega stickler when I walked around, like, oh, they didn't write the decimals, and so, I mean, really, all they're doing is they're showing you how you go from here to a decimal. It's just that they're building to what we're doing today. This, and I'm saying again, this is not my favorite strategy. It's a good strategy. It's okay. It's not my favorite. But it's just one of those backup roads that you might use if there's a wreck on the highway. If I have to get to work from Satsuma and I go, oh man, there's a wreck on the interstate. Okay, I'm going to go this way over here. So if there's, I need an alternate way. Sometimes you need another way. Because sometimes 2 plus 3 is not the only way you can get to 5. What about 1 plus 4? What about 6 minus 1? 5 times 1. So this is one of my other ways that I can get to 5. 10 divided by 2. So there's more than one way to do math. Okay? And so, and I'm going ahead and telling you, and I feel bad, and I'm not saying anything about the older people because I'm one of the older people, and I've said this before. Your parents, your grandparents, your aunts, your uncles, everybody, and you might be sitting there going, they have a hard time helping you with your homework because they look at this and go, what is this witchcraft? I hate this. Why can't they just do it? Common Core. Nah. This is not Common Core. Common Core is just they're telling us what to teach. They're telling us that we have to teach multiplying decimals. They're telling us what to teach, when to teach it. So, how to teach it is not. Okay? So all we're trying to do is show you different ways to make you think different ways so that you're not like we were with this is how you do it, this is the only way to do it, and if you don't get it, that's too bad. This is the alternate way. This is a different way. Because you know how you've got the ants that they're always in that one straight road and you know they've got that one path to get to that crumb on the ground, and if you block their path, they don't know what to do. They go berserk. Well, that's what has happened with, and I hate to say new math. It's not really a new math. This is the same math. But we've kind of put a blockade, you know, to the crumb. Okay? But curses! So we're trying to make you find an alternate route to the crumb. So we're showing you a different way to multiply decimals. That makes you go, oh, well I can turn it into a fraction if I want to. Now am I still going to let you take the tried and true way that we learned back in the day when we were like the Flintstones coming to school? Of course, because I showed it to you in first quarter. And that's why you're like, why are you showing me this? You already showed me how to multiply decimals. God, Strickland. I already showed you how to multiply decimals. But some of you multiply wrong. If you multiply wrong, you're really going to have a hard time with this. So you might need to go ahead and do this. But when we get into our bigger numbers, if you multiply 2-digit numbers incorrectly, you're going to have a hard time. Well, no, well, it all depends on where the decimal is, because that's 16, that's 19, this is 6/10. It all depends on where your decimal is placed. If it were, because we did do some bigger numbers yesterday, in our practice there may have even been some bigger numbers on the, no, not on this sheet. But if I make one up, and we had 6/10 times, is this what you're talking about? Yeah. Then it would just be 6/10 times 26/10. Because the 6 is in the 10th place. So then you just pluck that out. Because if you're looking at a place value chart, and if my decimal is there, and this is my ones, this is my tenths, this is my hundredths, this is my thousandths, if it's on the right. If this is 2 and 6/10, if I pull that decimal out, it's like Malena and Sierra. See? See, now I got what you were saying. 26 tenths. There are 20. Now I got what you were saying yesterday. That decimal is keeping them apart. Now I figured out, which is yesterday it was just like, blah, 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 blah. I didn't even get it. I was like, what are you saying? I'll look at that in a minute. Now, they're saying that there are 26 in that 10th place. 26 tenths. Because this is tenths, this is hundredths, this is thousandths. There are 26 of these. Shame y'all were absent.
On C, when you got 1600, isn't it supposed to be decimal 1/6 towards the hundredths, not towards 1 and?
And I was saying something else for her. She had said that she had put it over 10.
Or you can figure it out.
No, because I was here. She had said that she had it over 10. And I said you would have only moved it in one place. That was something totally different. Because right there I moved it in 2 places. And then I would just multiply it. Okay?
Mm-hmm.
Alright. So, what?
What do you do with the little square?
I ignore it. Okay. So, on the back, what's funny is I had some people who were totally fine with doing the one that was already filled in. And then they got down to G, H, and I and were like, I don't know what to do. So, it is not. It is not hard at all. So, or had totally different answers. Like this would be, I don't even remember what the numbers were, but like this would be 16, this would be 165, and then this would be 167. Should your numbers change at all? No. Your decimal should move, but the numbers don't change because the numbers don't change. There's a 1 and a 3 and a 5, a 1, a 3 and a 5, a 1, a 3 and a 5. The only difference is the placement of the decimal. The numbers don't change, just the placement of the decimal. Now, D, E, and F, again, a 7 and a 3, a 7 and a 3, a 7 and a 3. So there should be a 21 in there. A 2 and a 1, and the only difference is a decimal placement. But there's no work, so I don't even want it. So here I have 13 tenths times. It's not 5. Because it's 5, a whole number 5. So it's 5 over 1. 13 times 5. This is 15. 65. Please stop humming. 65 over 10. Move that decimal in one place. 6 and 5 tenths. 13 tenths times 5 tenths. Well, I already know it's going to be 65. 65 hundredths. Decimal goes in 2 times. 1, 2. It should be 13 hundredths times 5 tenths. Teacher Marco was absent yesterday, and he's like, bam, 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 with his answers. So we know it's 65 over 1,000. So I've got my 65. Decimal goes in 3 times. 1, 2. Ooh, hello, that's 3. I have to add a 0 in there. That's what you should have. There shouldn't be. Stop it. There shouldn't be any 1s in there. There should, it should. The only difference is decimal placement. Now, the word problems. Those are really what I want to go over because those are really what tend to give people the hardest trouble. And they are real world problems. Just like what we're going over today. And what's funny is the names that they throw in these things is what gives people trouble because they spend forever trying to read the name. Who cares? It's a name. Make up your own thing if you can't read it. So Jennifer makes 1 7/10 liters of lemonade. If she pours 3/10 of the lemonade in the glass, how many liters of lemonade are in the glass? What do you do to solve that? Have I taught you dividing decimals at any point?
Now,
17 tenths times 3 tenths is 20.
That's 51, Jacob.
It is not 20. 17 times 3, this is 21, which makes it 51. 51 hundredths. So I have 51.
More you decimal is 1.
Decimal 2 times.
Oh, 2 times.
Decimal goes in twice.
Yeah, I got that one wrong.
Okay.
Yep.
Two decimals. So it doesn't matter if it's decimal. Only you can take it out.
Oh, what, right here?
Row 8 on the top.
Well,
2 decimals.
well, I took this one and I put it, because the 3 is in the tenths place, so I put it over 10. This one's in the tenths place, so I put it over 10. Oh, look at that. Okay, so she has 51 hundredths of a liter in her glass. So I was making a joke about this problem earlier because Cassius, we must be in, some Greek mythology. We must be living in Roman times now. He walked 6/10 of a 3 6/10 of a mile trail. How many miles did he have left to hike? Can you solve this with only one step? No. This is a 2-part problem. So you should not only have one thing written. You should have 2 things written. So, what did you do to solve this?
I did 6 times 3.
So, he did 6/10 times 3 6/10 because he did 6/10 of 3 6/10. So 6/10 times 36/10. Now, again, this is not the only way to solve it, but this is the way that we've been doing it on the homework, so that's the way I'm doing it right now. So 36 times 6, 18, 21, 216 over 100 would be 2 16 hundredths of a mile. What do you still need to do?
You just subtract.
Put it in a mile.
No, I was my yellers, I was knowing to them. You would not simplify these because you need it over a power of 10. In order to move a decimal, it has to be over a power of 10. Jeremy, what do you need to do? How long it is minus what he's done.
So
And it will tell you how much he has left. 3 and 6/10 minus 2 and 1600. That's what he has left. 1 and 4400 of a mile left. This is your answer to that question. That's what he has left. So if you did only this, that's only half of the question. You didn't answer the question. Cameron was 1 and 3/10 miles ahead of Cassius. How many miles did Cameron hike already? So if you didn't answer A right, can you answer B right?
No.
No. So you have to be very careful with these problems where they're like one answer relies on the other answer. So what would you do, DeMarco?
The 13 times the one, that's what I said when you subtract it right now.
I wouldn't use this one because this one's telling me how much he has left. I would use this one because this one's how far he's done. Because this, he was ahead of Cassius, so I would use this one. This is what he's done. So, Cameron was 1 and 3/10 of a mile ahead of Cassius. So do I need to multiply or subtract or add or... I would add. If I multiply, my number's going to be pretty big. I just need to add because he's ahead. So this is where Cameron is. So what can I tell about Cameron? Well, she's almost done. That today's lessons will have some parts of what we did yesterday that are bits with extra work, but then we are going to have some parts that are where I'll say you don't have to do that, change it because I don't like it. And I'll say, repeat it, you'll hear me say kind of like the okay so's from yesterday. Where you hear me say a whole lot, I don't like it, cross it out. I don't like it, cross it out. So one of the things that we're going to do is, because we're going into the multiplying decimals, that I did teach you at the very end of first quarter. So we're kind of going into something that I've already taught you. So if we have 3 and 2/10 times 2 and 1/10. One of the things that they're wanting you to do, like we did yesterday, is take the 3 and 2/10 and make it 32/10. Just pluck out the decimal, make it a fraction. Take the 2 and 1/10 make it 21/10. The's nothing wrong with that strategy.
No. All you did was turn into a fraction.
And so, however many place values you have behind the decimal is what your denominator is.
Would it be how many zeros you have on the denominator?
Say again?
Like when you said how many numbers are behind the decimal, would it be how many zeros you had on the
Essentially.
I remember that when you said it last time.
So here I would do what I was calling yesterday my smoosh math. So I'm just going to take my top numbers, smush them together, my bottom numbers, smush them together. And this is when I would not try to do my simplifying in the problem because I have to have my power of 10 to do a decimal. So, sit up. 32 times 21. We do not multiply straight up and down. We are not adding. 1 times 2 is 2. 1 times 3 is 3. That's what I'm doing my 2. So I'm hearing you tell me how to multiply this correctly, so I shouldn't see any multiplying straight up and down.
Yes. 0.
So I'm adding a row, so I'm adding a 0. Because I'm not multiplying by 2, I'm multiplying by 20. So it shifts it over a place value. 2 times 2 is 4. 2 times 3 is 6. So I have 2 numbers here, so I should have 2 rows of numbers here. Yes, ma'am.
2.
So this is 2. This is 7. This is 6. So I should have 672 over 100.
It goes in 2 times, so it's 6, 7.
So I should have 6, 7, 2. I have 1, 2 zeros, 1, 2. Okay. Now, one of the things that they're telling you to do with engage, and you'll see it on the problem set, and I'll say that I don't like it. I don't know if them over there are telling you to do it over there. I don't care. Strickland doesn't care. She's going to tell you, please don't do it. I don't like it. To me, it's too much. And it goes too far away from anything that you will ever do. This, I don't mind this. This is okay. This is alright. I see it. I get it. This is not that bad. But the other one, I don't like it. Okay. There, I did that about 2 or 3 times already. I said okay so about 20 times yesterday. Then we started making fun of me, and that's okay. So here, I'm going to write in what we're doing here. So with this, we have the 3 and 2/10. What they're doing is the 32, they're writing what they're calling unit form. 32 tenths. And it was 21 tenths. Yuck. And so then down here you've got 642. No, that's not a 4. 672 hundredths. And for me, with tenths and tenths, and then you have to remember that tenths and tenths you get hundredths. I'm going to say again, I don't like it.
I don't like it.
That's so you'll see this on your problem set, and I'm going to tell you to be drawing lines through things. I don't want them doing this. So fractions, fine. If you like this strategy, knock yourself out. Do it. Not literally knock yourself out, but hold on. When you see this on your problem set, I'm going to tell you, do this. I'm going to tell you to do that. Because I'm gonna say it again.
I don't like it.
Okay. So this is the way that I taught you first quarter. When you see it with decimals, I'm going to tell you, you can do it with the fractions. If you like it, go for it. If not, then just multiply it using the standard algorithm. Because this is really the way that normal people multiply when they have decimals. Okay? So, we just do the 1 times 2 is 2. 1 times 3 is 3.
And the zero, and roll back 2 times because it's 2 numbers behind the decimal.
Okay. So, then we have the 2, we have the 7, we have the 6. Now, please stop with the pencil banging. So, one problem that I do run into that I see when people are multiplying decimals, get the hood off of your head. They look at the top, but they don't look at the bottom. They'll look at the top and go, oh look, a decimal, there's 1, and they only move it in once. You have to look at both numbers. And so what some people I told y'all to do first quarter was, here's 1, I need to move it in 2 times. Told you to write it up top, put it in a circle so you didn't forget when you were done multiplying. Does that sound familiar?
Yeah.
Okay, so then you're here, you go, oh yeah, decimal 2 places. 1, 2, done. 6 and 72 hundredths. Right, standard algorithm. Your parents will know this because this is how we learned how to do it when we rode to school like the Flintstones with our feet in the cars that were made out of rocks. Okay? So, stop it. I only saw this last year was the first time I'd ever seen doing fractions like this, but it's an okay strategy. I get it. You're breaking it down by place value. You're showing how it's made. You're showing how it's over hundreds. You're showing how you move it in. I get it. It's not that bad. So, but we always learned standard algorithm. There's nothing wrong with either one. But this is the one that you're really going to run into a lot. So, whichever one you prefer, really doesn't matter. They both, as long as you do it right. Just do it right is my thing. Just do it right. So, if I had 3 2/10 times 44 hundredths, you do not have to worry about lining up your decimals. You only do that when you're adding or subtracting. Alvin. You do not have to line up your decimals. Only when you're adding or subtracting. So I've got 1 up here, 2 down here for a total of 3. Four times 2 is 8. 4 times 3 is 12. Second number, add a row, add a 0. 4 times 2 is 8. 4 times 3 is 12. Add them up. There's 8. There's 10. I got people that will forget to regroup or carry that number, not add it. So it's really basic computation problems that are messing you up. 1 plus 1 is 2. 2 plus 2 is 4. And 1. Move my decimal in 3 places. 1, 2, 3. 1 and 408 thousandths.
Dang, that's a big number.
Yes, ma'am.
Why don't you line up the decimal?
Because if I did, it just makes it to where if I do this, Doesn't that make it look a little bit more complicated to try to multiply?
Ooh.
Because that makes it look really odd. And so then I feel compelled to have to do this. Then that gives me more numbers to multiply.
Would you still get the right answer, like the same answer? No.
Well, thank you, Miss Strickland. You became two children sitting in the classroom. So, but why make it harder? So, now that's 1, 2, 3, 4.
Oh my god.
You got the same answer, but you just caused yourself to have to do more work. So, why line them up if you don't have to? The only, it's quit making it harder than it needs to be. If you're determined that you have to line them up all the time, line them up, but then you just gave yourself another number to multiply. I mean, if you're just surefire determined that you got to line them up, but you're having to add another 0 in there, or 2, or 3. You just made it harder on yourself, which, as we know, you like to do.
So do I.
So, multiplying, you don't have to. And then 32 tenths times 44 hundredths. Because the last 4
The last 4 is
in the hundredths place. And I know that 32 times 44 is 1,408. Over 1, 2, 3. One, two, three. Yeah, I'd already multiplied it over here. I didn't want to multiply it again. I'd already done it. Yeah, I did that in my head. I'm that good. Yes, ma'am.
Why wouldn't you leave it a fraction and leave it a decimal?
Because up here, it's already in a decimal. They're wanting you to write your answer as a decimal.
It's like, write your answer as a decimal.
Express your answer as a fraction and a decimal. Really, it's just what the directions tell you to do. So what I'm going to do is I'm going to give you your problem set, and then we're going to look at a couple problems, and we're going to see really how easy it really is, and then we're going to really look at the word problems on the back, because that's the unfortunate side effect of running out of time. We never get to the word problems.
Yeah.
So we're going to work a couple problems and then focus on word problems. So I want you to look at the very first part with A. So with the fractions, that's exactly like we did it yesterday. It's not any different. They took 2 and 3 tenths and made it 23 tenths. They took 1 and 8 tenths and made it 18 tenths. And then they multiplied it. It's exactly the same. The only difference is they took 23 and 18, multiplied it, and then they put the words off to the side. And like I was saying, I don't like that. So what I would do, the only difference I would do is tell you not to do the words. Because the standard algorithm, I would leave this as 2 and 3 tenths. I would make that 1 and 8 tenths. Like that.
Oh.
Oh. And I would say, okay, now there's 1 decimal there, 1 decimal there. I need to move my decimal 2 places in with my final answer. And I would go 1, 2. My answer is 4 and 1400. That's the only difference from what they're telling me to do. I don't like the words. That's the only difference from what they've got. So with 2 and 3/10, how would I write that as a fraction?
Oh, you put 2, and then 23. 2 is a whole.
2 and 3/10 as a fraction, just like we did yesterday. How would I write that? Thank you. 23 cents times 9 tenths. So, Nine times 3 is 27. 9 times 2 is 18. Plus 2 is 20.
I know
1, 2 decimal places, so 1, 2 in would be 2 and 7 tenths. So 23 times 9 is 207 over 100.
Yes.
So yours should look like that, Mommy. So see if you can do C.
Okay.
$18 and 4,800. Okay. So 3 and 3/10, 1 and 4/10. So 33/10, because I said fraction model also, fraction and standard. 33/10 times 14/10. Since I've got to multiply these, I'm going to come over here and I'm going to multiply these. 3 and 3/10 times 1 and 4/10. I'm looking here. 2 decimal places. 4 times 3 is 12. 4 times 3 is 12 plus 1 is 13. Next number, add a row, add a 0. 1 times 3 is 3. 1 times 3 is 3. There's 2, 6, and 4. And you know, I had a derp this morning, and I multiplied those, and I wrote a 9 there. It was, wow. And they pounced on me like a puma on a little wild rabbit or something. They were just like, wham! They're like, check it out, my pants sticks! And I was like, oh, I was checking make sure you were paying attention. So, hey, you know, yeah, I wasn't lying. They were paying attention, and they caught it. So, you know, I'm only human. Sometimes I was multiplying in my head, and, you know, hey.
My sister's not humanist makes
So, I make mistakes too. I've got parades and SECME and school all in my head at one time. So, yeah, and you guys have archery too. So, 100 over 100, so 462.
Those are twice.
And decimal moves in twice. And I did not do my decimal over here, so now they don't match. So I have to make sure that I do my decimal going in 2 places over here. 1, 2.
Yes,
Right there.
again. No.
So you got that right. Awesome. Melena, you are rocking this week.
I know.
That's awesome.
I got cruising on a rock and roller coaster.
Let's just continue it throughout the semester.
Okay.
Okay. So they did the first one for you here on A. So 2 and 37 hundredths. So it would be 237 over what? Over 100. Because the 7 is in the hundredths place. You are right, Jamarco. 9 tenths. Now this one I would not, just because I don't like it, I would not use the words. I'm going to put those decimals back in there. Now, this is where, Melena, when you were saying, doing the lining up the decimals, if I do that, then I have to add 2 zeros in there, and that's a lot of extra multiplication that I really don't want to do. So here I would do 1, 2, 3 decimal places. So 9 times 7 is 63. 9 times 3 is 27. Plus 3 is 33. 9 times 2 is 18. Plus 3, 21. Go in 3 decimal places. 1, 2, 3.
Oh yeah, I got that one right too.
Yeah. So if I do 237 times 9, that's 2,133 over 1, 2, 3 zeros
1,000.
and 1.
That's all right.
2 and 133,000.
Put 4. What? Put 4.
Okay, so you guys have the idea on how to do the front. Pretty simple. Si, senor.
Yes. Hey, I have a French language for you.
That
It's
that sounds like gibberish.
French, I promise.
All right, escargot.
I don't know what that
That's snails. Okay. Okay, and then on the back, this is really the same thing of what was on the front, where it's saying solve using the standard algorithm, which we've done. That's what this is. So you're thinking about the units of your product. The first one is done for you. So they did the standard algorithm. Again, I don't like using the words. So I would really do 3 and 2 tenths times 6 tenths. And then you have to go 2 decimal places in. So 1, 2, 1 and 92 hundredths. So it's really the same thing that was on the front. Are there any questions about what we're doing?
No.
Are you sure? Because I didn't know how to do the homework. Okay. Because it's really the same thing of what we did yesterday. I really want to be able to focus on the word problems. We good? Parker, we good?
We're on the back. I thought we were still on the front.
No.
I'm done.
Oui, mon frère.
Y'all are already done with the whole front?
Well, yeah.
Y'all must have skipped.
Okay. Where were you?
I don't know.
Okay. So when we're looking at number 4 and number 5. Yes? No. So when it says on number 4, this would be a very good real world problem that happens anytime that you or your parents go to the grocery store. This happens all the time. This is how the cost of things is actually figured out. If your mom goes to buy steaks for the grill, your dad wants to go buy a roast or chicken, or you go buy some apples anytime something is priced per pound, or if you go buy more than one of something. So on this, you're going to go buy something and it's like you buy a pack of chicken, and on this is a pack of chicken breasts. You know, like the ones that you normally slice up, and it's the big fat flaps of chicken. There's no bones in it.
Oh, yeah.
And I normally, slice mine up. You could shred that for, barbecue chicken or whatever. You can make chicken fingers with that. Well, it's 1 2/10 of a pound. It's not a full pound. You can get 2 pounds, 3 pounds, 2.5 pounds, 4.5 pounds, 8 pounds. Well, on the package, they've already got it priced out for you. And then you might go, well, you probably don't think about it. You probably just grab the pack, or your mom just grabs the pack and throws it in the cart. But sometimes, I don't know if you ever hear, good Lord, this stuff is $8. Why is this package $15 for steaks? Oh my word! I do that when I look at like beef. Beef is expensive. But if each pound of chicken, this is actually cheap for chicken. If each pound of chicken is $3.70, 1 pound of chicken is $3.70. And she's buying 1 2/10 of a pound of chicken. Is it going to be $3.70 for the chicken that she bought? No. Is it going to be more or less than $3.70? More, because she's buying a pound and then a little bit more. A smidge more. 1 2/10. So, what would you do if she bought 2 pounds of chicken? Let's make it easier. Multiply it by 2. So, since she's buying 1 2/10, what would you do?
If I $3, it's $6.
If I'm multiplying by 2, why would I divide by 1 2/10? I don't know.
In another world.
I didn't teach y'all to divide anything yet, so why would we divide now? You're dancing around it?
It's 7.
It's 12.
Okay, so I've got a 12. I'm hearing 12 tenths times
337.
37
Over 100.
hundred.
Yeah, boy.
Or you could have always just done the standard algorithm.
Alright.
You could have always done the standard algorithm because these were already in decimals. You could do either one. Alton, you gonna write something? Now, oh wait. Does that 7 really have, does the 0 have a value here?
$4.
Yeah, it's $4.44.
$4. No, you know you did.
Oh, what am I doing? Sorry. Oh, I know. Can I blame it on a headache?
Yes.
And he was like, no, sorry. So I put the 37 over 10 because when you have this 0 really has no value. It's just there because when you're talking about money, you're saying that there's nothing in the hundredths place. You have to have it there when you're talking about money. It's just there.
So if you weren't talking about decimal, it would be 3 and 7 tenths.
3 and 7 tenths.
Now it's not the 3 and 7 tenths, 0.
Because if I have it down here, then I have to keep the 0 up there. It has to be 370 over 100. Does that make sense?
No.
If I keep the 0 up here, I have to have it over 100. If I just make it 37, then it has to be over 10. It's easier if you just do the standard algorithm, really.
Okay.
$4.44 with that lovely scribble that I did there in the middle. Because I wrote a 7. I don't know why. I like my 7s. They're pretty. They're just nice.
No, it's just like
44. So when she bought that pack of chicken, it would be $4.44. So now this number 5 is also something that you would run into if you ever. Are you writing down any work at all, or is it on that piece of paper? Thanks. If you ever get, when you're older and you have a house or whatever, and you get to where you want to know how big an area is, or you want to remodel, it does. Area. Something that you did in a previous grade. No. Area is length times width. Perimeter is adding all the sides, like a picture frame. Area is what's in the middle, like the picture. Right. So, okay, so area would be, like, say I wanted to know how many tiles I had to use to cover this floor. Say I'm like, man, these tiles are ugly. I want to put down some new ones. So, rather than measuring every single spot, I could take a tape measure and go, all right, and this is true because I have done home remodeling. I know how to lay tile. Okay, I have done it. All right, so I could take a tape measure, and I'm just making this up because I'm not measuring the floor. So I could go right here and go, okay, this is 20 feet. And I'm just going to, for the sake, say, okay, I'm going to get tiles that are 1 foot by 1 square foot. So, which these probably are. So, it's 20 feet this way, and I'm going to say 20 feet that way. I'm just totally making it up. So, 20 feet, 20 feet. I could multiply the length of the room by the width of the room. How long it is, how wide it is. So, 20 times 20. And I could say that I would need 400 tiles to cover the entire floor. Rather than going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and counting every single one. Just by measuring this wall, that wall. Doing the length and the width to give me a rough estimate of the area. Does that make sense? So, here, They're saying that the kitchen measures 3 and 75 hundredths of a meter, which that would be maybe the length, by 4 and 2/10 of a meter. So this way and that way. What is the area of the kitchen? So what do you do?
A square.
What, do you have to draw a square?
No.
You can do 3.7.
Don't draw anything. Just know that you've got to do length times
Width.
width. And I would recommend just don't even do the fraction thing. Just do a standard algorithm.
Okay. That's fine.
Just do standard algorithm. And when you do a unit times a unit, meters times meters, you end up with meters squared. Square feet, square inches, square meters. That's just something that you get later in the notes. Not times 2, it's times itself. Because you're doing meters times meters. That's why I said that the area would be like 400 square feet. One tile would be 1 square foot, because it's a foot times a foot.
So basically right now we're supposed to measure 300 times 4 and 2/10.
Okay.
Okay.
So, let me pick a different color. They're starting to blend together. 3 and 75 hundredths times 4 and 2/10. Again, you don't have to worry about lining up your decimals. Please stop writing in dry erase marker and do it on the paper. Please. This is 10. That makes it 15. That's set. Add a row, add a 0. And this is why I draw a line through mine. Because this one actually makes it 20. So I don't want my zeros to get confused. So this is 28, that's 30. That's 15. See, that's why I draw a line through my add a row 0. So this is 0. Hold on, Parker. Do what, Parker? Oh.
Whoa.
I didn't get what you said. 1, 2, 3.
Yay.
So it's 15 and 75 hundredths meters squared.
Yay.
Now, if you don't write your units correctly, your units of measurement, that's fine. I'm just throwing that little extra bit in there because eventually that will be a big deal. There's no C. But you do need to start getting used to writing your measurement unit in there because you could be talking about feet, inches, yards. Eventually your teachers will make a big deal about that. So you do need to get in the habit of doing that. And then earlier someone had asked me, can you do 2 different units like feet and inches and multiply those? And the answer is no. They do have to be in the same measurement. That's why we were doing conversions so much. You know, if this one had been feet and this one had been yards, you would have to convert one. Because you can't have 2 different units and multiply it. They have to be the same. Like you can't have, you know, cups and pints and multiply them. Either one would have to, you would have to change one to cups or change the other one to pints. You would have to change something. So,
What is improving?
meters squared. So the area of the living room is 1.5 times that of the kitchen. Find the total area of the living room and the kitchen. So I need this to solve this. And if I had done this wrong, then I wouldn't be able to do this. So the one thing we need to do is we need to figure out what this is, 1.5. So I need to be able to turn that, Demontre, into a decimal. And I know that some of you know what the decimal for 1.5. What is the decimal for 1.5? And it's always the same. It never changes. Yeah. You're kind of there? Yeah?
1.2?
No, that's 1 2/10. That would be something else.
So 1
No. 1.5. Because 1 5/10 is equivalent to 1 1.5. Oh! So, like you might, when you go buy a pair of shoes, sometimes you'll see the fraction, but certain shoes you might see 7.5.
So then on the 5,
You'll see like a 0.5 after the size. 0.5 always means a half.
But I'm a 5.5.
Yeah, I heard the 5 and I was like, you're kind of there. So I was like, I wanted you to try to, you were here and I wanted you to grab it and get it. You were there, but not quite. So the 0.5 always means a half. If it's 2.5, it's 2.5. 6.5, 6.5. So whenever there's a 0.5, it's a half.
Okay.
So 1.5 times that of the kitchen. What are you going to do?
5.75 times 1.5.
Yes, do it.
5.
So this is 5.
Wait. How did you get 8? Yeah.
So this is 25. This is 35. That makes it 37. This is 25. Plus 3 is 28.
Yes. Oh, that's why I'm doing that.
This is 5. This is 7.
Yes.
Add a row, add a 0.
Oh, wait, you ain't
Times-
done.
This is 5. This is 7. This is 5. This is 1. Goodness gracious. Can you close the door, please? This is 5. This is 12. This is 16.
8. Oh,
1 plus 8 is 9. Plus 7 is 16. Yeah,
5,
remember
2,
to do that.
6. Yes.
This is 8. This is 13. This is 2. There's 1, 2, 3 decimal places. 1, 2, 3. So the total area is 23.
That's the decimal, but I got mine.
Total area of the living room and the kitchen.
So now you gotta add.
So this would be
Plus.
the kitchen, 2-step problem. Because this is the kitchen, total area of the living room and the kitchen. So if this is the kitchen and this is the living room, plus The total area of both of the rooms. 39 and 375 thousandths of a meter squared. Yep. Total area of the living room and the kitchen. Total area of both. Well, you have to multiply and then add to do both.
Yes.